All right, let's take a look at an example that could be seen in the real world. So example number 2, a movie theater is pricing their tickets using the following function, where X is the number of tickets sold, that's the input, and Y is the total cost, the output, right? So they're selling tickets, right? You go to the movie theater, you buy some tickets, okay? They use an algorithm to decide, or a function rule to decide how much you have to pay based on how many tickets you want to buy, right? So let's look at number 1. Well, first of all, here's our function rule. Y equals 1150x. Remember, the Y value is the total cost, okay? And the X value is the number of tickets, okay? So input in the number of tickets into the function rule, okay? Do what the function rule says to do, and then it will output the total cost that you're going to spend, okay? So what are we doing to the number of tickets in order to figure out the total cost? Well, we're doing this, 1150x. So what does that mean? That means 1150 times x. So we're taking the number of tickets and we're multiplying it by 1150, okay? So multiplying 1150 times the number of tickets will give us the cost, okay, the total cost. That's what our function tells us, okay? So this is another way to write this function rule, all right? This is the variable way, and this is a more rules word way. All right, so let's look at number 1. What is the total cost of 3 tickets sold? How do we figure that out? Well, we take the number of tickets, that's our input, so that's 3. We multiply it by 1150, and we get our total cost output. So 1150 times 3. Let's do that on our Desmos. Okay, 1150 times 3, that gives us 34.5. 0.5 when we're talking about money means 50, so $34.50 would be our total cost here. So we're going to put that down. Anytime you guys are doing money, you want to have 2 decimal places, right? And then you want to have your dollar sign in front. Some people put it in the back. That's not where you want to put it. Put it in the front, okay? What is the output when the input is 1? Now we're talking math jargon, all right? They're not talking anything. They're not using any of the tickets or total costs or anything. They're just saying they're using math words, and they want to make sure that you understand the math words. So going back to the previous video, what's the output, what's the input, going back to previous things that we learned about functions. Input is the x value, output is the y value. Input's the x value, output's the y value, okay? So they're wondering, what is the output? That is, what is the y value? What is the y value when the input or the x value is 1? So they're saying the x value, which is the number of tickets, is 1. So how much is 1 ticket? We're translating number 2 into how much is 1 ticket, okay? So in math terms, what is the output when the input is 1? In this case means how much is the total cost of 1 ticket? Well, that would be 1150 times 1, right? And anything times 1 is itself. So that's a simple, easy one, $11.50. So you're paying $11.50 for each ticket. Just 1 ticket costs $11.50. Number 3, is it possible that 2 different families came to the movies and purchased the same number of tickets and had different total costs? Why? Well, in a perfect world, no, right? In 99 out of 100 cases, that's the case. Who knows? There might be some shady theaters out there that you might not want to go to. But in general, yes, it is not possible, right? No matter what group of people come in and purchase the tickets, you're going to have the same cost if you purchase the same amount of tickets. Okay, so we're going to say no, it is not possible, because each ticket costs $11.50 no matter what. If they purchase the same amount of tickets, they pay the same total cost, okay? And you're going to see that with a lot of functions, with all functions actually. Each input has a unique output. So no matter what input you put in, no matter what x value you put in, you should have only one possible y value. So In this case, a person shouldn't come in and try to buy 3 tickets and have to pay $34.50, and then another person come in and buy 3 tickets and only have to pay $30. That's not how it works. If you're buying 3 tickets, you have to pay $34.50. Okay, that's how functions work, and that's how this situation works. Let's look at example 3. A restaurant owner wants to raise her prices to create more profit. The below table is her original prices and her new prices. Find the function rule she used to create her new prices. So she used a function rule, okay, and she took her original prices that she had on her menu and she used this function rule and she came up with some new prices, okay? She raised her prices, and we got to figure out what was that function rule that she used. So we got to look at this table, okay? On the top is her original prices, and those are the X values for this function, right? Those are the inputs. She took those original values, she put them into this function, this computer, whatever, however you want to think of a function. I like to think of it as a computer. She put it into the computer, and it spit out some new stuff. That was the new prices, and that's our output, our Y values, okay? And we got to figure out what the function rule is. So how did the computer get to, or how did the function get to from the old prices to the new prices? What did it do? That's what we're trying to figure out. So we got to take a look at each individual price and try to figure this out. So let's look at the first one. The input, or the original price, was 99 cents. And then once it went through the function rule, it came out a new price of $2.99. So it looks like from here to here, okay, from here to here, we went up, what, $2, right? So plus $2. Let's see if that function rule, that's kind of what we're thinking the function rule is, but remember, it has to work for all of them. Function rule never changes for all the inputs. Every input has to go through the same function rule. So we got to figure out, did this function rule work for everything in the table, or is there a different rule that we're not seeing right off the bat? Okay, so let's look at the second one. $1.50 was the original price. That's the input, and then the output came out to be $3.50. So is that still adding $2? That is adding $2. Okay, the same thing is happening here. $2.18 comes out to $4.18. $5 came out to $7, and $11.50 came out to $13.50. So what is our function rule? Our function rule is add $2. Okay, that's what she did. That's what the function rule did to all her original prices. It took the original prices, added $2 to them, and now has the new prices. So she's moving up in the world. She's charging more. Hopefully people still buy her stuff. We'll see. All right, I'll see you guys in the next video.